All right, so last time, like I said, we saw multiplication and division. Today we're going to see addition and subtraction. Okay, so unlike, they're a little different. Addition and subtraction compared to multiplication and division. They're a little different, slightly different. They require some different approaches and steps. So generally, when you add in or subtracting two fractions, what is it that we need to have? Or what do we check first when you add into fractions? Everyone?
You said when you add in two fractions, what do you check for?
That's right. Malika.
Hi.
It's you. How are you?
I'm fine.
That they have the same denominator.
Right.
It's been a while, Malika.
I know. I'm back so I can finish this song.
I saw the name last time. I was like, that name looks familiar. But now that I see you, how's everything? How's everything with you? How you been?
Say that again.
How you been? It's been a while since before the pandemic, right?
Yeah.
All right. Welcome to
back
class.
so I can finish.
Okay, that sounds good. Sounds good to me. So don't let go again.
No, I'm not in this remote, so therefore I don't got it's no excuse now.
Okay, very good. All right, everybody. Sorry about that. So let's get back to fractions. What do you need to check for again when you have to when you add or subtract two fractions? The first thing you want to do is look at
the denominator.
That's right. So you need to check, for example, if you have. That's right. You need to make sure you have the same denominator. If it's the same, that's good. You can add or subtract. If it's not the same, you can't add or subtract right away. We need to do something else. We're going to look at it in a few moments. So luckily here, we want to add these two fractions. So we have 3 here, so that stays the same. You just need to add the top two numbers or the numerators together. That's 9 over 3. Again, the denominator stays the same. And at the end, make sure you reduce or simplify your answer. So what do you do here? 9 over 3 is basically just 3, right? 3 over 1 or simply 3. So
3 over 1, so then just 3.
That's right. Always make sure you simplify your final answer. Same thing applies to subtraction. They're almost identical in terms of the steps and what we need to do. The only thing difference is instead of adding, we subtract. But the other steps, as we're going to see later, are identical. So 5 over 2, for example, minus 1/2. So luckily, the denominator is the same. That means we can go ahead and add or subtract. So the denominator, again, will stay the same. You just need to subtract the top numbers. So we can end up with 4 here over 2, and that's 2. Reduce your answer. So when the denominator is the same, no big deal. It's very, very simple. Add, subtract, that's all. But it gets tricky when you have something like this, when the denominator is not the same. For example, 2 over 7 plus 4 over 3. It is not just adding these two and adding these two. That's very wrong. Don't do it. Now it seems easy and convenient, but that's wrong. Okay, that's not how it works. Maybe it works with multiplication, just multiply the tops, bottoms, but additional subtraction, it's not going to work that way. We need to find what do we need to have to add
the same common denominator.
That's right. So we need to find what we call the least. So the least common denominator. also known as the LCD. Okay, so before adding or subtracting fractions, we have to check for the LCD. You don't need an LCD, you don't need a common denominator when you multiply or divide. If this was a multiplication, you don't care about the common denominator. It doesn't matter, but it does matter when you have addition and subtraction of fractions. Let's take a look at this and see how to find LCD or how to add fractions. Find LCD first to add fractions. Let's do the same problem here, 2. Okay, 2 over 7 plus 4 over 3. So obviously, again, the denominators are not the same, so we can't just go ahead and add. We're gonna have to find out, we're gonna have to make these the same. We're gonna make these the same, and we do that by finding the least common denominator. Some of you may know what the LCD is here. Some of you may not, but I'll show you how to get it. What is the LCD, or the common denominator for 7 and 3? The LCD, or the common multiple or common denominator for 7 and 3.
It gotta be 21.
21.
Yeah, it gotta
That's
be
right.
21. Right.
That's right. That is 21. So let's see how to find that 21. So the LCD we said is 21. So basically what you do is you take both denominators. You write them down and you just do multiples of both. Meaning you take that denominator, you keep adding it to itself. You keep adding it to itself. You do the same thing with the other one, add it to itself. At some point, you'll see a common number between the two numbers here. That first number that you see would be called the least common denominator. So let's do that for 3 and 7. What is the first multiple of 3? You just basically keep, 7.
14.
14. That's right. Basically just keep adding 7. Add another 7.
And then it's 21.
21, add another 7. 28 and 7. And then we'll do the same thing. Someone has background noise, please mute your mic if you have background noise. Then we do the same thing with the 3. The first multiple would be
6.
6, that's right. Then
9. 12. 18.
15.
Okay.
18. 21.
And 21. As you can see here, we have a common number or a common multiple. So common denominator or common multiple, pretty much the same thing. So, but with experience, and also if you know the multiplication table, it makes it a lot easier to see the LCD. You kind of see it quickly. So make sure you load your multiplication table at least from 0 to 10. This will make this a lot easier. Not only simplifying fractions as we saw last time, but also when finding the LCD, you can just look at the numbers and you do this math in your head, you can quickly figure out the LCD. So that's why we say the LCD is 21, because it's basically a common multiple, a common denominator or a common multiple of the two. The first one. There are other common multiples. If you continue, there's got to be other numbers, but they are bigger. You want the denominator to be the least, the smallest one, so you can do the math faster and easier. You don't want to use a big LCD because it would make the math more complex and you'll have to simplify and so on. So that's basically why we call this the LCD. So most of the time, again, you can figure it out just by looking at the numbers. If not, feel free to do this. Feel free to do this in order to find the LCD. So once you find the LCD, once you find your LCD, what you want to do is we're going to take these two fractions, change them into new fractions with the same denominator, with the same common denominator here, which is 21. So we're going to turn them into new fractions so we can add. Because when you have the same denominator, you can go ahead and keep it and add the two fractions. So let's see how to turn this fraction first into a new fraction with, instead of 7, we're going to have 21. And also we're going to turn this into a new fraction. Instead of 3, we're going to have 21. How do we turn 7 into a 21? Or in other words, how many times does 7 go into 21?
3.
3 times. That's right. So we're going to multiply this by 3. It becomes 21. Then you're going to times this by the same thing. That's right. So if you increase or if you double one side, you have to double the other side proportionally. That way, you don't change the value of the fraction. It will still be the same value, but with different numbers. So always times the top and bottom by the same thing here. 7 times 3, 21. 2 times 3, that's 6. We call these equivalent. This fraction 2 over 7 and this one, they may not look exactly the same, but the value is the same. So we call them equivalent. Equivalent fractions. Okay, so let's turn this one into a new fraction. This time we're going to times by
7.
By 7, and here times by
7.
7. 3 times 7, 21. 7 times 4 would be 28.
28.
That's right.
Professor,
So
I have
now,
a question.
Go ahead.
When I was learning fractions in school a long time ago,
Hello.
and we were multiplying and
Maybe you just multiply these two and multiply these and these, right? Multiply this way.
They made us turn the second fraction backwards.
No, that's for division. You mean flipping this?
You cannot do that when you're adding?
No, that's for division. So we flip this only if you have a division. I don't know if you were here last time, but when we have division, we keep change, flip this. But for addition, we do not flip this. We find a common denominator.
Okay.
We did it last time.
So equivalent. So we call these equivalent. The values is still exactly the same. And now that we have the same denominator, we can go ahead and add. So what do you get? The denominator will be
34 over 21.
34 over 20.
That's right, 34 over 21. And as always, try to reduce your fractions. Please mute your mic, whoever has that background noise. Someone has background noise. So try to reduce it if possible. Is there a number that goes into both 34 and 21? Is that a common number that we can reduce like we did last time or factor out? Nothing goes into 34 and 21, okay? So that's basically, that's how you know this can't simplify because nothing goes into both. Even if you break this down, this is 17 times 2, this is 7 times 3, so none of that would cancel. But what type of fraction is this?
Improper.
Improper. So we can turn the improper into
A proper fraction.
A mixed number.
Into a mixed number. That's right. Into a mixed number. 21
number.
Right. 21 goes into 34.
One time.
Right. What is the denominator here?
21.
And here, what's the
13.
remainder? Remainder would be 13, right? 21
13.
goes into 34 once, and 13 is left from that. That's right. So this is a remainder of the division. That's the same denominator, and this is how many times this goes into this. Again, this is what we discussed last time, simplifying, converting, and so on. So after adding or subtracting, make sure you reduce your answer if possible, and also simplify it. Simplify it first before turning it into mixed number when possible. All right, so that's addition. Let's do another one. Another one is subtraction. 5 over 6. And this will be subtracted. So as you can see here, the denominator is different, so we can't subtract. So we need to find an LCD. What is the LCD, or the least common denominator, for 6 and 4?
2.
What is the least common multiple or denominator?
12. 2.
12. So 12 is right, 12. So it's not
18.
always this times this. Okay, so it's not always 6 times 4. Some of you might be thinking it's 24, but it's not. It is a common denominator, but it's not the least. This is the least one. Because again, if you do the multiples, let's do the multiples for 6 and 4. That's the reason why you shouldn't always multiply these two to get that set. It's not, well, it doesn't always work. Maybe here it works. 7 times 3 is 21. That's the LCD, but it does not work for all. So if we do the multiples again, 6, then 12, then 18, then 24. If you do the multiples here, that's 8, 12, 16, 20, 24. As you can see, we have this as a common multiple or denominator. That's the least one. 24 comes after. 24 is also a common denominator, but it's not the least. There's only one least, the first one. That's the one you want to use because that would save you time, save you a lot of troubles. So you want to go with the least one so you can do the math faster. Sometimes the LCD could be small, and if you multiply the two numbers, it gives you a large number, 100 or 200, and that's can be. All right, so that's the LCD.
Professor.
So, yes?
Yeah, why you not get the other 24? Why you say, because you say it come after?
Because this can also be a common denominator, but it's not the least. This will also give you the same answer, but it will take you more time and you're gonna get a big fraction here. You need to simplify it first, but this one is easier and quicker, right?
Okay, thank you.
So, all right, so now we're gonna turn both of these. So once you find the common denominator, you'll write two new fractions with the same denominator, that LCD you just found, and basically convert or turn these fractions into new ones. So 5 over 6, we want to turn this into a new fraction with 12. We're going to times it by
2.
By 2. So 6 times 2 is 12. Also here by 2. Then you're going to multiply 1 over 4 by
2. 1 over 4 by
3.
Right, by 3. 4 times 3 is 12.
Yeah.
Times 3 is 3. So the new equivalent, equivalent fractions. So 6 times 2, that's 12. 2 times 5, that's 10. 4 times 3 is 12. 1 times 3 is 3. Now we have no problem subtracting. That's right. What's the result now of this subtraction?
7 over 12.
7 over 12.
Professor, I sent you a picture of what I meant to your email.
Okay, I'll check it out later and see. Okay, so that's it. That's our question. As you can see, you don't have to reduce this. You see it's only reduced, nothing goes into 7 or 12. It's also proper. That's why it's convenient and practical to use the LCD. If we use 24, it's got to be a larger number here that you still have to simplify. So always go for the least or the lowest common denominator. Okay, so again, it's not always multiplying the two. I'll show you when you can multiply the two right away. The denominators to get the LCD. There's a way where now you can just multiply. Before that, any questions about any of this, everybody? Good. Questions here, everyone? Okay, so if not, let me show you. So basically,
so this one, sir, we just leave 7, 12 like that.
Yes, because you can't do anything. You can't simplify it. You can't turn it into a mixed number because it's proper.
In
Proper,
this
it's
case,
improper.
why can't we make it 1 and then
because 12 does not go into 7. 12 does not go into 7. This is proper. Okay?
Sorry, yes, of course, it's
21
a bigger number. Yes, okay,
exactly.
got it.
Okay, so here's another problem. Let's say maybe 2/9. Let's add this to maybe 1/3. Sometimes the LCD can be right here. The LCD can be one of these.
Okay.
So you don't have to do any of this.
18.
It's not 18, the LCD. LCD is not the least.
It's 9.
18. It is 9. So sometimes your LCD can be right here. Okay, it can be one of these.
You just have to multiply
right?
the second fraction.
You just have to multiply that one. But here's how you figure out whether the LCD is here. So sometimes you don't even have to do any of this. The multiples or something else. You can find your LCD right here. It could be one of these. That's when one of them goes into the other. If one of the numbers goes into the others evenly, meaning a specific number of times, that's your LCD. Only if one goes into the other. So your LCD is right here. You don't need to do any multiples or anything. Okay, and here the reason why, for example, this one 6 is not the LCD, it's 12 because 4 does not go into 6 evenly. 4 goes into 6 only once, and you have some change. Also here 3 does not go into 7.
Awesome.
3 goes into 7 twice, but you have a leftover. But when one of them goes into the other one evenly, for example, 3 goes into 9 how many times?
No,
3 goes into 9.
3.
That's right.
3.
Goes exactly 3 times. So if it goes exactly or evenly, then that's your LCD. The larger one is the LCD. So right now, so instead of using 18 or 27 or some other bigger number or 54, we can actually use 9, or we can do the math faster. Good news is you don't have to change this one. It already has 9, it stays the same. So this one, no need to change anything, already has 9. This one we need to change into a fraction with 9. So the first one again stays the same. Second one, we need to multiply by, make it into
3.
9, right, by 3, both sides. And this, again, doesn't change, no need to multiply. Think of it as 9 goes into 9 once, or 9 times 1 is 9. So basically, you're not changing it,
Okay.
just multiplying it by 1. So this stays the same, right? And this one here, 3 times 3 is 9, 1 times 3 is 3. And as you can see, we did it right away. Now, the result is
5 over 9.
5 over 9. As you can see, it's also like this one. It's simplified. It is proper. That's the final answer. Imagine if you used 18 or 27 or 54, you're going to have to do some work. It's going to add a couple of steps to your work. So try to use the least common denominator. And the quickest way, or the first thing you want to try is always see if one goes into the other. So 9, we could say 9 is the LCD because 3 goes into 9 evenly. Okay, 3 goes into 9 evenly. That's important. So if that doesn't work, so that's the first thing you want to try. Always see if one of the denominators goes into the other. If it does, yeah, that's your LCD. If it doesn't, then there's 2 more things you need to check. Let me give you an example to illustrate the next step. So let's say you want to add 2/5 and maybe 4/3. So always again, try this. First of all, is the LCD here, or can 5 be the LCD? So 5 is not the
No.
LCD because 3 doesn't
It
go into
doesn't
5.
go. Mm-hmm.
That's right. So that's first step is gone. So that's the first thing we'll try because I could save you time. Secondly, you may multiply the 2 to get the LCD. You may multiply, just multiply them right away. You can say LCD.
15.
That's right. It would be 5 times 3, which is 15. The only time you can multiply these is for the short time when you're 100% sure that's the LCD if both are prime. If these both are prime, what is a prime number again from last time?
A number that can be multiplied with 1 in itself.
Right, can be divided by 1 by itself. In other words, a number that you can't break down. You can't break down the 5, you can't break down the 3. That's how you know your LCD is. Just multiply those right away. Even without even doing this. You can still do the multiples, but you can save all this simply by multiplying. So 15, or we can say the LCD let's see. Something is wrong with my computer. It's acting up. So again, the LCD.
I do have a break at 7:30.
Okay, let me close this and reopen it. Something is not right here. Just a second.
One time.
Okay, let's see. I hope I don't have to restart the computer. Let me see if I can cancel something here. It's heating up.
It's better.
All right. Let me restart this. And let me try this again, see if it works. If not, I'm gonna have to restart the computer. So what I was saying is the LCD.
So LCD is 15.
Yes, the LCD is 15.
Mm-hmm.
It's 15. In other words, It's 5 times 3. Because both is 5 and 3 are both prime. Okay, so that's important. So you can find the LCD here. If the numbers are prime, don't worry about the multiples, don't worry about anything else, just times the 2. Just times the 2. So first see if one goes into the other. If so, the higher one would be the LCD. If not, second thing you want to try is this. Are the numbers prime? For example, 7 and 13. So if you have 7 and 13, you know they're both prime. So no need to waste time doing the multiples. You can still find the same one, but just times the 2 right away. So in this case, our LCD is 15. But again, we just need to multiply, turn these into new fractions. First one, we're going to times it by to make it 15. That's right, by 3 here. Also here by 3. And the second one by
5.
5.
That's right. That's right. So that's 6 and 20. And again, add your numerators. The denominator will stay the same. It's 26. Okay. Always try to reduce the fraction first. Before turning it into a mixed number, try to reduce it. Can we reduce it first? Anything goes into both?
Yes.
Anything goes into both? Well, what goes into both? Nothing really goes into both, right?
Nothing.
Yeah, so can reduce. Now we can go ahead and turn this into, we can turn it into a mixed number.
Improper fraction.
Isn't it supposed to be 29?
You become 1 over
29. Why 29?
Because 3 times 3 is 9, and then it becomes
2. This is 2.
It's 26.
This is 2. It's 2 times 3 is 6. 6 plus 2 is 29. So now we can say 15 into 26 once. Same denominator.
11.
And 11.
Okay,
11.
that's right. That's 11. Right. So 1 and 11. That's your final answer. Always simplify if you can. Try to simplify. Simplify first and then turn it into a mixed number if it's improper. So you want to try this first, then try this if that doesn't work. And if these two don't work, the only thing left to do is rely on your multiplication table skills or do the multiples. So if these two don't work, so just go ahead and do the multiples, or sometime again, because of the multiplication table, you'll be able to see the LCD. For example, here, 4 and 6. 4 does not go into 6. And also they're not prime, so we didn't multiply them. So just by thinking about the multiplication skills, you can table, you can say 12, or you may do it this way. If you can't see it, it's 12, just do the multiples. And those are the 3 tricks to find the LCD, and it can be very quick. Make the math faster. So now we'll see how to, but before that, let me give you one last example. Let's say you have, so 5 over maybe 11 minus or plus 2 over 3. What's the LCD? In a few seconds, what is the LCD for 3 and 11? Think about the 2 steps. Try the first step and the second step.
33. 33.
Exactly, 33. 33, why?
Both of them are primes.
That's right. So, exactly. So 3 doesn't go into 11 evenly. So we try the prime thing. Both are prime. So LCD right away is 3. Or if you do the multiples, you can still find it the same one, but it will take you a little bit of time. You're gonna have to do this. You're gonna have to do this. So, but if you think about the primes, you can do it quickly. So 11.
33.
So both basically will turn into 11. You're going to times this by, you're times it by to make it 11. That's right. 3 here also. And here by
11.
11.
That's right. Also 11. So this will be 15 here. 2 times 11.
22.
22.
That's right.
And then
33 and
then 10 and 10, 36. 30 what?
37.
37 over 33.
That's right. As a mixed number, it would be 1 and
1. The 1.
and
4 over
33.
4, 33.
exactly 4 over 3. See how we did this faster? So we didn't even have to do any math on the side because of this. Because we know with the LCD, we use the smallest one possible. And it was pretty simple to do, basically without needing a calculator, without doing any multiplication or math on the side. And if the answer you get is simplified, if it's not proper, you turn it into mixed number. So basically that's how you find LCD. We'll give you another one, another common example. 3 maybe over 8 minus 1/6. So just by looking at the two numbers here, what do you think the LCD is?
They're not prime.
These are not prime, right? But actually, this is not a very good example. Let me give you another one. This is not what I want to illustrate. Let's see, 18 and 9.
24.
18 and 9, let me see, 18 and 9. Let me switch these a little bit. So we have 5 here, for example, and 1. So you want to subtract these. So what do you think the LCD is? What's the LCD for these two?
I would think 18.
It is 18.
9.
Yes.
18.
It is 18 because 9 goes into 18 twice. So the higher one is the LCD. It's not always this times this. If you times them, it's going to be a large number. It's still going to be a common denominator, but it's not going to be the least. So 18 and 9 goes into 18, that's it. No need to do the multiples, no need to multiply the two. The LCD is right here. So you don't even have to change the first one. Already has 18, stays the same. You just need to change the second one. We're going to multiply
By 2.
Oh, sorry, by 1.
By 2.
By 2 to make it 18.
I mean, by 2.
By 2.
Okay.
I
That's
think
right.
I'm looking at 18.
Okay, so this, we need to make it 18, same denominator. 1 times 2 is 2.
3 over 18.
3 over 18.
That's right, 5 take away 2, that's 3. 18, near a distance fraction. So, now. Can you distance fraction? Can you simplify it, in other words? It's simple. What goes into both these numbers?
3.
3. So, in other words, like we did last time, to simplify, we break down the numbers. So 3 times 6. We look for a common number to cancel out. So 3 is a common number. We cancel that out. We end up with 1 over 6. Okay, so always simplify your fraction. It's proper. So you don't need to write it as a mixed number, it's proper. And that's pretty much it. So that's how you find the LCD, these 3 methods. Try this, try the multiplication. If not, use the multiples. Okay, any questions, everybody, so far, before we move on to mixed numbers?
I have a question, but it's about the homework.
At the end, we'll do that at the end. Okay, any questions here, everybody, about
yes,
this?
the number, that's exercise with it. The number 2 from where comes from?
I'm sorry, say it again?
The number 2, here it says 1 times 2.
What times 2?
I was wondering from where it comes from number 2.
So because the LCD is 18, so we want to change, we want to turn both these fractions into new fractions, both with the same number. So this one already has 18, we didn't multiply it. We needed to multiply, or we needed to turn 9 into 18. We needed to turn 9 into 18, so it times by 2, also times by 2.
Okay.
In that way, we end up with the same number. That's the reason why we use LCD.
Okay. Equals 1.
All right. Okay, so now let's see. Any other questions, everybody?
No.
Please let me know if you have any other questions. So next we're gonna go to, we're gonna see how to add and multiply, add and subtract mixed numbers. So far we've done fractions. Everything was fractions, adding to fractions, but sometimes you may have mixed numbers. You may need to add them or subtract them. So we have, so last time we multiplied and divided mixed numbers, and this is how we add them. So let's say you have 1 or actually no, 5. So maybe 5 and 1/3. Add this to maybe 2.
So, sir, you said before it was simplify in fraction, and these are fraction with mixed numbers.
We have to turn the mixed number into a fraction.
Okay, okay.
That's right.
Oh, just the opposite way. Got it. Thank you. Thank you.
Right, right. So most of the time we will have to do that. So let me again think about an example. So let's say you have 6 and 1/5. You want to add it to another mixed number, maybe 3.
You add the whole numbers first.
Okay, that's right. So when you have addition of 2 mixed numbers, that's right, 2 mixed numbers, we can you can add the whole numbers together, especially if you have this. If you have the fractions with the same denominator, it's easier to just add the 2 here together. So 6 plus 3, the whole parts. Then you add the fractions together. So 1/5 plus 2/5. So from here we'll have 9. And what is the sum of these 2 fractions? 3.
3/5.
3/5. This is convenient, especially if you have the same denominator, you can do this, and you have addition. With subtraction, it does not always work. It's a lot of confusion with fractions, with subtraction, so I do not recommend doing the same thing with subtraction. I'll show you how to do subtraction in the next step. So this was easy, just add the wholes together. If you have the same denominator, add the 2 together. If you don't have the same denominator, you need to find the common one. Okay, so you have to find a common one. I'm going to see an example of that later. But before that, let me give you another example. Sometimes you may be adding just a whole number and a mixed number, for example, 2/5 or 2, whatever it is, 2/5, for example. It's another problem. In this case, if you have addition of a whole number and a mixed number, it's simple. Just add the 2 wholes together. 7 plus 3, that's it. The fraction remains the same because there is no other fraction here. So we just, fractions stay the same. So that's 8 and 2/5. Again, this only works for addition. For subtraction, it may or may not work. So do not attempt it with a fraction unless you're sure about it. Now let's see what happens if you have different denominators here. We're also going to see what happens if you have a minus here. So if you have 8, for example, 8 and something else, or actually take some smaller ones. 2, 1/3. You want to add this to maybe 3. Yeah.
I have a quick question. How did you get 8?
Me too. I was just about to say that.
Just said the same thing.
I have no idea. I have no answer.
Supposed to be 10.
7 plus.
Maybe I was.
You mean
thinking
10,
about,
right?
Maybe I was thinking about 1 here or something. I have no idea.
You mean 10?
Sometimes you do things and you're thinking about other things. 10 over 2/5. Okay, we just added the two wholes together. 10 over 2/5. 2 and 1/3. Let's try to add this to maybe maybe 1/4 here. So as you can see here, so it might not work as this one because the denominators are different. So instead of adding the wholes together and the fractions together, let's actually convert both of these into fractions. That's right. Just make them like this. We're going to turn them into this and repeat the same thing again. So what is, how do you turn this into
7 over 3?
That's right. 2 times 3. 7 over 3. Plus
12 over 4. I mean 13 over 4.
That's right. 3 times 4 plus 1, that's 13. And 4. So no more mixed numbers. We have fractions. We just learned how to do the LCD and everything. And now, as you can see, we can't add it right away. We need the common denominator. So what's the LCD here for 3 and 4?
12.
12.
12.
12.
That's right. LCD is 12.
Yeah,
this is basically, we did it with the multiplication table. You thought about the multiples. So 3 times 4 is 12. And of course, we're going to turn both of these fractions, both into new fractions with this denominator. First one, we need to multiply by
28,
4.
the first one.
We need to turn this into 12, so we need to multiply it by
4.
4.
Okay. This we're going to times
by 3.
3, and let's get this.
28 on the first, and then on the second.
20.
I don't even know.
And 39, right?
39.
Okay, so 39. And
over
again,
12.
Same denominator. Add the 2, that's 50. 67, right? 67.
67.
Okay, and always try to reduce.
Turn it into a mixed number.
Okay, first reduce it if possible. I believe 67 is the prime number. I think, yeah, nothing multiplies into 67. You can turn this into a mixed number. How many times does 12 go into 67? You can always do the multiplication and division on the side. Divide 67 by 12.
What the fuck?
5 times. 5 times, which is 60. So 12 goes into 67 5 times, which is 60.
And
Same
then
denominator.
7 over 12.
7 over 12. 12 into 65, that's 60. 5 times, and yeah. Again, if you can't do it easily, feel free to do the division on the side. This is a remainder of the division. Do it on the side, and you don't have to do it in your head quickly like that. Feel free to do the division. So, so every time you add in or even subtract in mixed numbers, sometimes it can be easy like this, quick. If you notice it, you can use it. If not, this always works. This always works. Whether it's addition or subtraction, you can always convert into mixed numbers first, and then, into fractions first, then find LCD. Let's do one with subtraction.
Question, Professor.
Mhm.
If you give us an exercise in which you can add up the mixed numbers, but we do it, turning it into fractions, will it be wrong?
No, you can do it any way you want. That's fine.
Okay.
As long as the final answer is right. I'm sure you guys have maybe other methods you are used to. That's fine. You can use those. You don't have to exactly use my method. You know, everybody comes from different backgrounds, different systems. So all that matters in math is the final answer. Of course, the steps, you show the steps, but also the final answer should be the same. So let's do another example here. Let's say 7 minus 2 or 3 1/4. Maybe something else, 2/5, just to change things a bit. You can make this one maybe 1. So this might not work as this. So do not be thinking about just subtracting 7 and 1 together and adding this to it. It's not gonna work. It may work for addition, but it's not gonna be the same. So it's just you turn everything into fractions. Different types of numbers, whole number, mixed
7
number.
over 1.
That's right. So this could be 7 over 1 minus, turn this one into a fraction also would be
7 over 5.
That's right. 1 times 5 plus 2 over 5. And now we have just regular fractions, and we can do the same thing we just did earlier. What is the LCD for 1 and 5?
5.
5, because 1 goes into 5. Or, okay, actually think of it this way, 1 goes into 5, therefore 5 is the LCD. In other words, whenever you have 5 and another number, I mean, whenever you have 1 and another number, whatever number it is, that number will be the LCD. So 1 and any other number, the other number will be the LCD. So you want to make them both 5. You don't have to change this one because it already has 5, stays the same. You just need to turn this one into a new fraction with 5. So you're going to times it by. You'll multiply this by what number?
Wouldn't the answer to that be 0?
Possibly, maybe not. Let's first. So this, again, stays the same. We need to turn this one into a new fraction with 5. How do we turn this again into?
Oh, 21 over 5.
By 5.
Times it by 5, times this by 5. So now 1 times 5 is 5. 7 times 5 is 35. Again,
Okay.
this one stays the same because it has the same denominator. And of course, what is the answer here?
28 over 5.
28. So as you can see, different types of numbers. Turn them into the same type of numbers, maybe into fractions in this case. Find the LCD. Can we reduce 28 and 5? Anything goes into both? Nothing, right? Nothing goes into 28
No,
and 5.
Nothing.
So
a mixed number.
Can reduce. Or we can write as a mixed number. 5 into 25, into 28.
5.
5 times.
And then 3 over 5.
That's right. So 3 over 5. So if you see mixed numbers and subtractions, it's you need to convert everything. Maybe with the addition of mixed numbers and whole numbers, you could probably find a quicker way. But again, unless you're sure of it, if you're not sure about it, feel free to use the conversion here. So that's subtraction of basically a whole number and mixed number. Now we'll see how to simplify or how to subtract two mixed numbers. Any questions first? Any questions here? Anybody? Before we do another example. Please let me know if you have any questions.
Yeah, can you repeat what happened with the 5 next to the 7? Like 7 times 5 and then 1 times 5. Where it,
So
how we got
had,
the 5?
Because 5, because it's the common denominator. So we want to change both to the same. So the LCD here is, LCD we said is 5. The LCD for y 1 and 5 is 5. So we wanted to turn the fractions into new fractions, both with 5. This one already has 5, stayed the same, but we had to turn this one. You had 7 over 1. You had 1. So to turn 1 into 5, we multiplied it by 5. That's why
okay, yeah, I got it.
Also multiplied by 5. And now let's see how to subtract two mixed numbers. Maybe 11 minus, actually 11, maybe 2/3. That's a really big number. Actually, let's actually make it smaller. We don't care about large numbers for now. So 2 or 3 and 2 or 1/2. From this, we want to subtract this and maybe 2/5. Or anything else, 2/7. It doesn't matter. So it's not going to work. If you think that we can just subtract the whole numbers, subtracting the fractions can be tricky. So you still have to find the LCD. So you need to turn this first into proper fractions, improper fractions. That's right. 2 times 3 plus 1 is 7 over 2.
So, sir,
9 over 7.
How do I know which question I mean it's clear here. I can subtract 1 from 3, but you said it's not always work. So how do I know?
But how are you going to do if you subtract 3 from 1? Then you still have the fractions here. 1/2 from 2/7. You still have to subtract those. So you need to find the LCD. You don't know which one is larger of which, so just convert them into mixed numbers, okay? So even if you subtract the whole numbers, you still have to subtract the fractions. You still have to find the LCD. That's why we need to convert everything first. Convert everything to.
Okay.
So this one.
That's why I turn everything into fractions because it's easier.
Yeah, that's the standard way. Just remember to turn everything into mixed numbers, into mixed improper first. Don't worry about these tricks here. I just gave you that as an idea, but you don't rely on it too much. Follow the same steps with everything. So turn this here. 1 times 7 plus 2, that's 9.
9 over 7.
That's right. So now that looks familiar. We just need the LCD. What is the LCD here?
14.
That's right. Both are prime. 2 times 7 is 14. Again, that's because they're primed. First, 2 doesn't go into 7. That's why 7 is not the LCD. Instead, we times them because they're both prime. If they're not prime, then you have to do something else. You have to do the multiples and so on. So this is 14. Again, we're turning both of these into same denominator, the LCD. We're going to times this by 7.
7.
7. And this one by
2.
2.
Okay, and also 2. So
14.
49.
49 over 14. 18.
That's right. And once you have the same denominator, you can go ahead and subtract, keep the denominator the same. 49 minus 18 is
31.
31. And once you get to the final answer, 4 ways it can reduce. Before you convert, reduce it. See if you can break it down, cancel something. 31 is a prime number, so nothing cancels. And since it's improper,
14 can go into it twice.
2.
Go twice. That's right. Twice.
And
the denominator is 14.
14.
What's left from 30? What's left from 31? 3, right? Because twice is 28. 28 from 31 is 3. That's the final answer. It's reduced. Another thing is, especially if you start a question with mixed numbers, you answer not only should be, but must be a mixed number, especially if you start with mixed numbers.
Okay.
This is still good answer, but tell you the reason why it's important to do so. When you take a computer test, if they give you a question like this and give you options, this would be one of the options, not this one. So you need to know how to convert this answer into this. So computer option would be something like this. Is it this? Is it 5 1/3 and so on? But even if you do it correctly on paper, but you don't see these options here. So that's how you know. You need to turn it into this. And if you turn it into that, you'll see the answer that matches the options you are given. So always, as much as possible, try to convert your answer when possible to mixed number. And okay, so that's pretty much the only extra step here is converting. Once you convert, that's it. You find the LCD again using all these steps here, all these methods apply. So just like with multiplication and division last time of fractions, we just had to convert mixed numbers first, and then we did the same thing again. Simplify, reduce first, multiply, and so on. All right, any questions, everybody, about any of these problems or anything that we saw today? Everybody? Everybody's good? No questions asked?
No question.
Mm-hmm. Let's see what else. Yeah, so that's pretty much basically the idea here. We keep doing the same thing over and over again. Let me give you a couple of fractions or a couple of questions to practice on your own.
Professor, can you check real quick the picture that I sent you to see if I can do that?
Okay, let me first write the practice and I'll
Okay, thank you.
Practice and I'll check it out. Practice. Okay, everybody, so let's say you have 1/5, you want to add the 1/5 to 2/7. And 5. A subtraction here. And also okay, so 2 1/6 plus 1 3/8. Okay, this should be good. Let's see. It's another one. Maybe in one last one here. So 5 1/3 minus 2. Just a few of those here. All right, so give it a try, everybody. Try to follow the same steps. And I'll check with you in a few minutes. I'm gonna go over this together. So I'll give you about 10 minutes or so. And I'll be back. I'll be back in a few minutes. Okay, everybody, are you done?
Mm-hmm.
Okay. Everybody else? Finished?
Yeah.
Couple of people, okay.
Yes, I'm done.
Everybody?
Ready?
All right. So let's go over these together, everybody. What is the LCD here?
It's 35.
35, that's right. They're both
35.
prime. That's right, they're both prime, just times them. So the LCD is 35. That times here by 7, and here by 5 and also
by 5.
By 5.
7 and 10.
Against
So this will
17
be
to 35. 17
10
to
over
35.
35 and then 10
75.
over 35.
That's right. So it's proper.
70 to 75, right? You cannot do nothing.
So can reduce that, right?
You
What
cannot
about the
reduce.
LCD here? What is the LCD here?
15.
It's a 15.
That's
Yeah,
right.
15 and a half.
Because 5 it goes into
15.
15. That means that's
Yeah,
the LCD.
15.
So that's right, 15. No need to change this. It has 15 to stay the same. This we're going to times by
21. 3.
That's 21.
by 3. That's right. 3, 7 times 3 is 21. Then,
Of course, you carry over, and then you're gonna have
19 over 15.
19 over
15.
That will be
Okay.
1 over
5.
1, 4
That's
over
right.
4 over 15.
4 over, that's right,
15.
15
Correct.
into 19 once, 15. We have 4 left from that. Right? Next one, you have a couple of mixed numbers. What is the first thing we do here?
You're gonna
Turn them into fractions.
That's right. Convert into fraction. What's the first fraction?
13 over 6.
13 over 6.
That's right. And the other one?
11 over 8.
That's right. And I mean 6 here, not 7. 6, the denominator stays the same. 6. Okay. What is the LCD now for 6 and 8?
24.
24.
That's right. 24 is the least. It's not always good to multiply. If you multiply them, it's going to be a large common denominator, 48 or something, but you don't want to use that. So 24. So you do the multiple. So here, 6 doesn't go into 8. That means 8 is not the common denominator. Also, you can't just multiply them because they're not prime like this. So the third step is to make sure you do the multiples, or think about the multiplication table to find the least common multiple here, which is 24. So we're going to times this by
6.
4.
Oh, sorry,
4.
4.
4 again.
And 4. And here by
And 3.
5.
3 by 3.
3 and 3. Right?
Oh,
8
sorry.
times 3 is 24. 11 times 3 is
33.
And over here?
39. 39.
No, that's more. That's
50.
that's 26, 52.
52.
That's right, because we times in by 4. So that's 24. Add these two. That's 80, right? 85.
85 over 20.
That's right. How many times is 85 going to, or 24 going to 85?
It definitely goes into twice, and then what
Twice.
is it? 8, right? Twice at
That's
18
right.
over 24.
So 24 twice is 50, is 80, is 48, right? 48 out of 58
Right, 10.
is
Sorry.
10. Exactly.
Right.
That's 10. This twice. We have
You just have your numbers backed up. You have 58 instead of 85.
I was like, it's just me or
oh wow, I do that quite often. Always, I think backwards. A lot of time, you read things backwards. It's got to be something with my brain. Okay, 85, right? 80, and so that changes things a little bit. Okay, now, how many times does 24 go into 85? At least 3 times, right? It's no more than 3 times.
Yeah, absolutely.
3 times, which is?
It's 3. It's definitely gonna be 3 times.
3 times.
And then
that would be 72, right? 72.
Exactly.
If we take that out of this, it would be 3 and 13, I believe.
13.
13.
Okay, and that's our final answer. You don't need to do anything else. Okay, so again, convert, find LCD, multiply, and convert if you have to at the end. Last one here, what we need to do first?
Minus the whole number.
And then is 16 over 3.
Okay, convert into fractions. This is 16/3. Take away 2 over
2/1.
1. So now we have
I did it different.
Okay. So now the
just
LCD
minus
here is
2 to 5.
that might work if it's in this order, yes. But if it's
Yeah.
in the other order, if 2 is first, then it will be confusing. That's why.
No, the number that has to be along has to be the second number.
That's right. So it works if you have a certain order, but it's good to have one method for all. So I don't want to teach you too many methods, so it can be confusing. What is the LCD here, everybody? For 3 and 1?
3.
So if you have 1 and a number, it's always the other number. That's right, 16. This stays the same. To turn this into 3, we're going to times it by
3.
By 3, also by 3. That's 6. And this would be
10 over 3.
That's right, 10 over 3.
10 over 3.
Okay, what is this as a?
It's going to be 1 over 1/3.
That's right, so 3 times, I mean, not 3, I mean 3 first. 3 into 10 3 times.
Over 1/3. I got the same answer the way that I did it. 5 minus 2.
That's right, you can do just 5 minus 2. You can get to this. But again, if it's 2 first, minus 5 over 3.
It won't work out.
Or whatever number here, it's not going to work out. If you have 12 minus 5, it's not going to be just 12 minus 5 and 7 over 30. It's not going to.
No, you have to minus the whole number to the mixed number to be able to do.
That's right. If you know the tricks, you can use them. Like this one and this one, you can use them. If you can't see them, that's fine. It's not a problem. One method's for all. This is one method for all the problems. It's consistent, so you don't have to. So it's not confusing.
How does it go if you do the other way? I think somebody did it. She did 5 minus 2. How does it go? If
that can be confusing. It's just 5 minus 2 is 3.
I did it the way you just showed, but
this one.
If she got the same answer doing 5 minus 2, how does it go?
Yeah, you just subtract the whole numbers.
If the number that you're minusing from the first number is smaller and it's a whole number, you can do it. But if it's backwards, you cannot.
That's right. It's confusing, so don't worry about it. That's why I didn't want to tell you about it. Just stick to one method, everybody. So stick to one method, convert into fractions, find LCD.
I did it that way too.
And if you know those shortcuts, if you know those tricks, you can use them. But with experience, you will actually see them. For now, just stick to the standard method. And the more you do it, the more you can figure out those shortcuts by yourself, and you can use them in the future. For now, one method works forever. Okay, any questions, everybody, about these problems here?
No, we're good. I mean, actually, I understood. I thought I was going to be really confused at this point, but no, I'm okay.
All right.